Okay, so the last section, yay, measuring matter. So this one has a lot of practical application. So we'll first talk about accuracy and precision, and then we'll talk about the application of measuring matter in the medical field. So accuracy and precision are very important to think about when you're making any kind of scientific measurement, right? Like if you're trying to give a patient a test for something, you want to know how accurate and precise that test is. So your textbook has this neat little example, and it has this football player, and he's kicking a football, right? And there are 3 different football goals, right? Let's draw all 3. Okay. And so what we're worried about with this football player is he being precise, or is he being accurate, or both? Okay, so what if he kicks the football, and each of the 3 times we go 1, 2, 3, that's where the football ends up. Well, he's kicking the football and he's getting it into the goal every time. So I want you to think about that. That's the goal. So if your measuring is accurate, you're getting the goal. So here, even though they're kind of all over the place, they're all within the goal. So that would be accurate. So you are accurate, right? So that means you're taking measurements that are close to the true value, or the actual value. Now, precise. What if this football player kicked it, and 3 times he got 1, 2, 3? Look how tight that packing is of where he kicked that football. Well, that's great. He's getting it in the same place every single time, but is he getting the goal? No. So he is precise. He's hitting that same place over and over and over again, but it's not actually close to the actual value, the goal. What you really want that football player to be is you want him to be, let's see if I can move my picture up. You want him to be both precise and accurate. So let me just do it down here so that you can actually see it. So what I want this football player to kick the football 3 times in a very tight pattern and in the goal. And that's what we want in our scientific measurements. We want them to be both accurate, and we want them to be precise. And so we do this to verify this. We take our measurements multiple times and we average those values, right? You should not take just one measurement. That would not be good. All right, so you as a healthcare professional will be using the SI or metric units, but you also have to be kind of familiar with what we in the US tend to use, because that's what your patients are going to be familiar with, right? So we typically say pounds, but the SI unit is a kilogram, right? All those kind of things. So if you have to use these as a conversion factor, you'll be given a table like this, but you have to be able to use them. So whenever you're taking samples from patients and you're doing testing on them, you're going to get results, and you're going to be looking at the units on those results, right? And they could be a range of things, and we're going to talk about what they could be. So if the result is out of a range, it's going to be highlighted from the lab, right? They're going to tell you, oh, this is out of range, but you have to be able to read those reports, like a blood analysis report, right? So it's kind of hard for patients to look at their results. And so what they do to make it easier on the patient is that all the results are listed to where their values are greater than 1. But what happens is it makes the units vary widely. So I want to show you, your textbook has a nice one. So here, let's see, where is it? Here we go. Here's our sample blood chemistry. Right? So the result, this is the patient's result. All these results, do you see how they're all greater than 1? It's easy for most people to look at numbers that are greater than 1 than numbers that are less than 1. So what they've done is they've changed the units to make the values greater than 1. So if you come over here and look, all of these units are different. Look, this is milligrams per deciliter, and deciliter, can't write on the screen. Deciliter is 100 milliliters. So this is milligrams per deciliter. This is grams per deciliter. This is micrograms per deciliter. So you have to be able to understand what that means. So if we go back, ooh, that wasn't the right thing to go back to. Okay. So you have to be familiar with the metric units that you're going to see on these kinds of testing results, right? So we saw deciliter. Deciliter is one tenth of a liter, or 100 milliliters is what we said. Millimoles, a lot of times you're going to see that. Milli, the little m here, stands for 1,000, right? So 1 millimole is 1,000th of a mole. So it's 1 over 1,000. And we'll talk about moles later on. But sometimes you're looking at electrolytes. Does the patient have the correct one? And so we call these milli equivalents. But it's still milli, so it's still 1/1000th, right? And we talked about in the US, we use pounds, but when you're talking about pharmaceuticals and how much to prescribe to someone, they're not going to say on the thing, give them so many grams per pound. They're going to say give them so many grams per kilogram. So you have to be able to convert. So we're going to do a lot of dosage calculations with this one in a minute. And it's the same thing as when you're doing a normal dimensional analysis. You want to figure out where you're going. So what are my units for my final answer? What am I starting with? That's my given information. And then usually you're going to have to use multiple conversion factors in order to cancel the units to get to that final answer, right? So you want all your other units to cancel until you get to that goal unit. And we're going to do some examples in a minute. But let's talk about a few other things. A lot of times you're going to deliver medicine in an IV. In an IV, the medicine is dissolved inside of a liquid. And so you're going to measure how much of that liquid you're giving somebody in drops per milliliter. And the Latin for drops is abbreviated GTT. So sometimes you're going to see that GTT per milliliter. And so this is called the drop factor, and it's used to determine the drip rate. So how many drips should this patient be getting over however much time, right? And so depending on the size of the tubing, if the tubing is very, very narrow, it's going to have a very slow drip rate. But if the tubing is very wide, it's going to have a very fast drip rate. And the last one that we really need to talk about is percents. There are a couple of different places that you're going to see percents. You're going to see percent active ingredient. So like, for example, if you prescribe someone to take aspirin, that big aspirin, or relatively big aspirin, is not a whole lot of actual active ingredient of the drug. There are oftentimes you're only prescribing really a small amount of the active drug, and it's really hard to handle that small of an amount. And so what they do is they mix the active ingredient with something else, and that something else is a binder, usually it's like a starch or something like that, and it increases the size of the pill so that you don't basically lose it. Another time you're going to see percent is when you're talking about dosing a child, because you don't want to give a child the adult dose because their body weight is different. So they'll say, 50% of a normal adult dose is what you want to give the child, or something like that. And then you'll also see percent in nutritional labeling. Nutritional labeling will tell you how much carb or protein or fat, how many grams, but a lot of people don't think about this. How many grams of protein should I have? And so we convert that to a percent daily value, and it shows how much you should get in a percent wise. And that's easier for people to understand in terms of a dietary requirement rather than grams. People just don't think about that, right? All right, so at the very end of this, there's a little study guide so that you kind of have a summary of all the things that you need to have covered for our last section. Okay, so let's go back. We're gonna do a few practice problems. This is kind of cool, right? All right, so let's really briefly go over some accuracy and precision. All right, so we're gonna toss horseshoes. Anybody ever played horseshoes? You know, the little, looks like a horseshoe, looks like a U, and you throw it at the pole and you want it to hook onto the pole, right? So you toss 3 horseshoes, none of which lands near the center pole. You're not getting the goal, and the horseshoes are scattered all over. So this is neither precise, so this is neither precise nor accurate, right? You're not hitting the goal, and you don't have a very good packing of your throws. They're all over the place. That's me playing horseshoes. Tossing 3 horseshoes, and all 3 are ringers on the center pole. Every single one got exactly the goal. Wow, that is both precise and accurate. That is not me. And then the last one, tossing 3 horseshoes, and all 3 land in front of the center pole on top of another. So they haven't hit the goal. They're close, but they haven't. They're 3 feet in front. So they're all tightly packed together, right? But you didn't get the goal. So you have good precision. Precision only, right? All right, let's see. Oh, here we go. Remember I was talking about aspirin, right? So a low dose of aspirin is recommended for patients who are at risk for coronary artery disease. You're going to prescribe them a low dose aspirin to prevent coagulation of the blood so that they don't get blood clots. And so we know that a low dose aspirin contains 81 milligrams of acetyl salicylic acid. That's the active ingredient. So how many grams of this active ingredient of acetyl salicylic acid will a patient take over the course of 5 years if they take 1 aspirin tablet daily? All right, so what are we trying to get to? We're trying to get to how many grams will a patient take over the course of 5 years. So that's our goal, right? That's what we're trying to get to. What are we given? Well, we're told that a person is getting 81 milligrams, and I'm just going to abbreviate this, acetyl salicylic acid. I'm just going to abbreviate it that way. So I'm tagging. Remember, tag, tag, tag. Show those units and tell me what it's for. Per tablet, okay? So per 1 tablet. And I want to know how many grams am I going to get of acetyl salicylic acid per year if we take 1 aspirin tablet daily. Okay, so 1 tablet, we're going to take 1 tablet. So I want my units to cancel. What conversion factor can I use that has the tablet? Well, I was told, right, that they're going to take 1 tablet per 1 day. All right, now, if I want to go from days, what am I trying to get to? I'm trying to get to years, right? So I know I have 365 days, right, in 1 year, okay? And how many years is this patient going to take it? They're going to take it for 5 years. And you don't have to have anything on the bottom because you're just saying they're taking it for 5 years. And my last thing is, I want to know how many grams. I'm currently in milligrams over here. I don't want to be in milligrams. So I need another conversion factor. Ooh, this is just how I do my, you can draw your line all the way across, right? There we go. Okay. So I want milligrams on the bottom. I want grams on the top. How am I going to do that? I know that milli means 1,000. So I have 1,000 milligrams in 1 gram. So now do I have the units I want? Okay, well, let's see. So my tablets cancel, my days cancel, years cancel, and then my milligrams cancel. So this is how many grams? That's the question. How many grams am I going to take over the course of 5 years? So if you plug that into your calculator, you get 147,825 grams. But are my significant figures correct? No, they are not. So how many significant figures? 2, we have 5.0, 8.1. That's both 2 significant figures. So that is going to give us 150 grams of acetyl salicylic acid. And you can write in 5 years, right? Okay, let's try another one. Give drug X 5 milligrams per kilogram per day in 2 divided doses. Ooh, the patient weighs 44 pounds. How many milligrams should be given per dose per day? All right, our goal is milligrams per dose, and then, so our goal, let's write it, is milligrams per dose, and we want to know milligrams per day. All right, so what do we start with? Well, we're told, right, that we want to give this drug in 5 milligrams per kilogram, right? Per day. So I'm going to say per day. So I'm just dividing again. So now I want to know how many milligrams should be given per dose. Well, how many milligrams depends on your weight, and the patient weighs 44 pounds, but we're in kilograms, so we can't stay in kilograms, right? So if I know in 1 kilogram we have 2.2 pounds, right? And there's a conversion factor in your textbook, a table that has that. So now I can say that my patient weighs 44 pounds, right? Because what am I left with? My kilograms cancel and my pounds will cancel, so that's great. So this will give me 100 milligrams per day, right? Because all my other units canceled. So this gives me milligrams per day. So that's my first goal. Let's see if I can highlight that. Here's my milligrams per day and my milligrams per day. So that answers half of the question. So I'm not done. I got to keep going. Now I want to know how many should be given per dose. I want to know milligrams per dose. So my milligrams is okay, but I want to get rid of my days now. So how am I going to get rid of day and then get dose? Am I given a conversion factor? Yes, because I know in 2 divided doses, this is what we're going to give per day in 2 divided doses. So I know in 1 day, the patient's going to get 2 doses. So that should be 50 milligrams in each dose. Okay, make sense? All right. Let's see our next one. Let's see, a 38-pound child is prescribed. No, that's not the one we want to do. We want to do 1.57. Okay, a child is prescribed morphine sulfate at 50 micrograms per kilogram per dose. The child weighs 85 pounds and the solution is available as a 5 milligram per milliliter vial. How many milliliters should be injected? Okay, so what are we going to do here? Well, what are we starting out with? We're told that we have a 50, right? Microgram, right? Per kilogram, per dose, all right? And so if you want to say I should have given y'all more room on this one, right? Per dose, okay? So I have to base this on the weight. I'm trying to get to milliliters injected. So here's my goal, milliliters injected. I have to base this on the patient's weight, but I can't do that in kilograms. So I have to convert. I know in 1 kilogram, I have 2.2 pounds. Now I can take into account their weight. And their weight said it was 85 pounds. But I'm in micrograms, right? Well, I'm given the solution in milligrams per milliliter. So I can't stay in micrograms. I want to convert over, and I like to go back to the base unit. I like to go back to the gram. So I'm going to say, I know in 1 gram, I have 1, and I'm going to write it in scientific notation, times 10 to the 6 micrograms. So what do I get? I get 0.00193 grams per dose. Let's make sure my units cancel out. Micrograms, kilograms, pounds. So I'm ended up in grams per dose. Great. Now, I'm not quite there yet, right? So I know I have grams per dose, but now I need to convert to milligrams, right? So I'm going to do another conversion factor, and I'm going to say I have in 1 gram, 1,000 milligrams. And then it's telling me that the solution is available as a 5 milligram per milliliter vial. Well, I want to get rid of milligrams, so it's a 5 milligram per 1 milliliter. I'm at my goal. How many milliliters should be injected? Here we go. 0.39 milliliters, not very much, right? Okay, so that gives you a good sampling of some of the different dosage calculations, right? Okay, so the last one that we're going to do, we're going to talk about percents, right? So in this case, a tablet of Benadryl, which is an antihistamine, has a total mass of 0.5 grams. It contains only, even in that 0.5 grams, only 25 milligrams of the active ingredient, diphenyl hydramine, HCl. And it should be an L, not an I. What percent of the tablet is the active ingredient? So if you remember, how do you determine the percent of something, right? So we know the grams of our part, right? Grams of our active ingredient is equal to some percent of our total tablet, total grams of the tablet, right? So this is supposed to be an A, active. So how do you figure this out? Well, you could just plug and chug, but you got to be careful. This grams of the active ingredient is in milligrams. It's not in grams. Here, our mass of the total is in grams, but you can't do percents if your units aren't the same. So be very, very careful that you get those units correct. So the first thing I want to do is convert this 25 milligrams into grams. So how do I do that? What I'm going to do is I'm going to tag. So I'm just going to put my little shorthand for my drug here. And then I'm going to say, I know in 1 gram, I have 1,000 milligrams. Okay. So I do my conversion, and that gives me 0.025 grams of this active ingredient, right? So now I can plug into this formula, do it in a different color. So I'm going to plug into this formula, my grams of my active ingredient, 0.025 grams of my active ingredient is equal to some percent of the tablet. And so the tablet is 0.50 grams. That's my total grams of the, I want to say aspirin, Benadryl. I'm running out of room there, but that should be Benadryl, right? And so how do you get that percent? You're going to get rid of that and you're going to put it over 100, right? Okay, so what is my percent? X percent is equal to 0.025 divided by 0.5, and you should get 5%. So when you take a Benadryl, that little pink Benadryl, only 5% of that is an active ingredient. That's kind of crazy, right? So we were saying there's not a lot of active ingredient. It's mostly filler inside of the medicines that we take. All right, that is the end, and we'll do some more practice problems in class.